has long puzzled scientists. Despite its abundance, dark matter does not emit, absorb, or reflect light, making it invisible and detectable only through its gravitational effects. While its primary role in shaping galaxies and the large-scale structure of the universe is well established, recent theories suggest that dark matter might have far more profound implications, including the potential to unlock the mysteries of time travel. Dark matter's existence was first inferred from its gravitational effects on visible matter. Observations of galaxy rotation curves and gravitational lensing revealed that there must be more mass than what is visible. This unseen mass, now called dark matter, interacts primarily through gravity and possibly weakly through other unknown forces. Physicists have proposed various candidates for dark matter, including weakly interacting massive particles, WIMPs, axions, and sterile neutrinos. Despite extensive efforts, no direct detection has been achieved, leaving its nature an open question. Time travel has been a topic of fascination in science fiction and theoretical physics. According to Einstein's theory of general relativity, massive objects warp spacetime, creating phenomena like black holes and wormholes. Wormholes, hypothetical shortcuts through spacetime, could theoretically allow travel between different points in space and time. The challenge lies in stabilizing such structures. Wormholes, if they exist, are predicted to collapse almost instantaneously. To keep them open, exotic matter with negative energy density, something not yet observed in nature, would be required. Could dark matter, with its mysterious properties, play this role? Several theories explore how dark matter might intersect with the concept of time travel. Exotic matter hypothesis. Some researchers speculate that dark matter could include exotic particles capable of generating negative energy density. If true, dark matter might provide the stabilizing force required to keep a wormhole open, enabling time travel. Dark energy link. Dark energy, another cosmic mystery, is thought to drive the universe's accelerated expansion. Some models propose a connection between dark energy and dark matter, suggesting that their interplay could influence spacetime in unexpected ways, potentially creating conditions conducive to time travel. Hidden dimensions. String theory and other advanced frameworks suggest the existence of extra dimensions beyond the familiar three of space and one of time. Dark matter might interact with these hidden dimensions, providing a mechanism to manipulate spacetime more directly. While the idea of using dark matter for time travel is tantalizing, significant challenges remain. Experimental verification. Our understanding of dark matter is still rudimentary. Without direct detection or a detailed understanding of its properties, these theories. Conclusion. Could dark matter be the key to time travel? The idea remains highly speculative, but it underscores the profound mysteries surrounding dark matter and spacetime. As our understanding deepens, we may discover that this elusive substance holds the secrets not only to the structure of the universe but also to the nature of time itself. Whether or not time travel becomes a reality, exploring these questions will undoubtedly expand the frontiers of human knowledge.